Welcome to this video. We are going to look at a two-dimensional projectile motion question. It's very interesting. It says an Alaskan rescue plane drops a package of emergency rations to stranded hikers as shown. The plane is traveling horizontally at 40 meters per second at a height of 100 meters above the ground. Where does the package strike the ground relative to the point at which it was released? And B says, what are the horizontal and vertical components of the velocity of the package just before it hits the ground? So we are looking for the part A is looking for the where does the package strike the ground? So meaning up. Let's say it falls somewhere there. We were just assuming that it falls somewhere there. So when they say how far relative to the point it was released at this particular point. But to be relative, it's more like to be opposite. So our relative point is there, meaning we're looking for this particular distance there. Okay, that's how far we are going. And that particular distance from the point of release to where it will be dropped, it's what we call the range. Okay, capital what? R1. Now, range is just distance. And we know that distance is given by speed multiplied by what? Time. So our range is equal to velocity multiplied by what? Time. But the question is, do we have the time? We do not have the time taken, so we are going to calculate the time taken using the vertical component. All right, so let's find the time taken. So to find time, we use the y component. All right, so we are going to say the change in y, all right, is just equal to y minus y initial. Now this is what will give us time. All right, so say y is equal to, okay, this will be initial velocity minus 1/2, then gt squared, like that. Now this is where we need to be very much careful, okay, because it is right there. All right, so our y, remember that this friend of ours was dropping down, so our distance will actually be in the negative one because it was going in the opposite direction. That would be negative 100. Initial velocity, okay, in our case is 0, so meaning everything here becomes what? 0 minus 1/2. Gravity is 9.8 and t squared. Okay, now that we have done that, we can just get your calculators, because we are having negative 100 equal to negative, should be 4.9 t squared. So we divide throughout by t by 4.9, meaning our answer is the square root of 100 you divide by 4.9, because negative and negative will cancel. So the time I'm getting is 4.5 seconds. So now that time is known, we can now find the range. Velocity has been given to be 40 meters per second. Okay, so 40 multiplied by 4.5, and I'm getting my range to be 181 meters. That's all. But you can also call it just range in the x, that to be sure, isn't it? All right, so that's all. The B says we need to find the horizontal and the vertical components of the velocity. Okay, the horizontal and the vertical components of just now be careful, this is not the initial, this is more like the final velocity. All right, in both x and y, just before hitting the ground. So just before hitting the ground, meaning there will be velocity in the x, and there will also be velocity in the what? In the y. And this is what they are looking for. They are not looking for the initial velocity. All right, but we know that anything to do with the x component, all right, meaning our velocity in the x, will always be initial velocity times what? Cos theta. And our initial velocity is 40, okay, right? 40, then cos, this is the angle is 0 degrees. I'm still getting 40.0 meters per second. I'll still get the same because there will be no change there. But for the y, okay, we need to be very careful because now here the plane or whatever object was being dropped is now falling under the influence of gravity, meaning in the y it will not just be, remember we have u, remember v is u plus at. You remember this equation, right? Okay, now let's just take it into sine, since in the y we deal with the sine theta. So this u, it will be initial velocity sine theta. Okay, then it will be minus gt. Okay, like that. So vy will be equal to, this was 40. No, in the y, sorry, in the y we do not have, because in the beginning, like from the point of view, you can see the arrow there, it was only concerned in the x, meaning in the y there was no velocity. So all this part is 0. Minus g is 9.8, and the time that we found was 4.5. 4.5. So velocity in the y, I'm getting negative 4.3. I'll leave it 1 decimal place, meters per second. Now you can tell to say this is negative, and this is very interesting because look at the arrow. The arrow is going down, meaning this part will be negative, but this one is going to the positive part of the x axis. So this completes the equation. This is projectile motion. All right, very important topic in foundation physics or introductory physics. We do offer tutorials, very affordable. Please inbox us and register as soon as possible.